Hello and welcome to Explain Rust Analyzer, a video series where we try to understand how Rust Analyzer works one query at a time. So last time we were looking at the item tree structure in the here dev crate, and one thing we've noticed is that there is one linear lookup in the file AstID map thing, which seems surprising to me because it feels like this function should be pretty hard and it actually should make the thing significantly slower than it otherwise needs to be. So this time, let's just try to do some ad hoc live coding and see if we can fix it and whether it is actually a problem. Don't know where this is going to end. Maybe we'll fix it, maybe we will not fix it. We'll see. Okay. So as a reminder, the way to generally benchmark Rust Analyzer is by running this analysis stats command, which now takes quite some time to run for Rust Analyzer's own code base, which is rather big at this point. I wonder how big Rust Analyzer actually is today. Uh, So if I'm reading this correctly, this is like 250,000 lines of code. That's not small. Yeah, it used to be so much faster. Yeah, while we are doing it, actually, let's also run Cargo xtask bb baseline to build baseline Rust Analyzer binary, which will be used for benchmarking and to compare against. Okay, so it takes roughly a minute to process. Should make this faster. It doesn't make sense that it takes this much time to process Rust Analyzer. Like it's just like horribly slow. Okay. So I'm now trying to find. Yeah. So this is the thing which feels suspect. In that here we do linear lookup, and if we do this for each item, we have in AstIdMap, and that would be quadratic, and that would actually be quite slow. And we do this. I think somewhere here, AstID. Yep, AstID equals erased AstID, and that that's a function pointer. So that feels suspicious to me. I guess let's actually test the hypothesis that this indeed is quadratic. I think we somewhere, yeah, assert linear is probably what we to use here. Like we do we actually use it anywhere? Like why is it so slow? Yeah, but use it. Yeah. Should be faster. Yeah, so let's just copy paste this test and see if this is working. Okay, let's actually like remove this accidentally quadratic stuff, which apparently doesn't work, and instead do something simpler. Many. Okay, and here I want to do something like let's try to not make it completely trivial. So right now I want to just hypothesis that we actually quadratic. For that, I want to generate a giant file with like many functions and see how long does it take to highlight this file dependent on the number of functions. And to do this, I actually need to write a function which generate many functions, and I want to test this is actually correct. And to do this, I need to be more creative about is it Quadratic? To be more creative about function names. I hate this code window management. Okay. Smoke. Foo0, foo1, foo2. Yeah, that makes sense. I guess that maybe make them pub just for spice things up. Okay. And now let's print and elapsed and see if the thing is actually quadratic. And the thing obviously panicked. Okay. Write benchmarks. It's sometimes useful to add assertions to make sure just that you benchmark the right thing. Okay. Curiously, it doesn't seem particularly quadratic to me, which again is surprising. Actually, let's run command line and run this fully in release mode. See, it seems rather linear so far. Like make n twice as big and the result get twice as big. Let's see what release build shows us. Oh, okay, so it's doesn't seem like it is completely linear. Okay, yeah. Right now we see that it's it clearly is not linear. And yeah, kind of like how do I test for linearity? The left-hand side is incremented by 2, is multiplied by 2 on every iteration. So you see that I iterate for e in like small range, but then I define my n as actually 2 to the power of I. And I expect you will mess all my output. So things on the left go steadily, and the things on the right. Okay, now we just actually we are hitting the artificial parser limit, so let's remove it to see how far we will actually go. Okay. And while the thing is running, let's actually look at how we can fix it. So we have this arena which maps indices to syntax node pointers. And I think the way we want to fix this is to add a hash map here. Which maps index node pointers back to indexes. So how do we create this thing? Yeah, it seems like we only have one constructor here. So we should just backfill a map here. Let's try to do this. Hash maps, index nodes, here. And what it should map into is a raised file, AstID, and then I think what we want to do here is to say self map.getPTR. You actually can. Can just enough, or else panic with that thing. Yeah, that seems like it should do the trick. And yeah, you see it's like slightly worse than linear. And that actually means that our assert linear test is like not working. And yeah, I actually wish someone to go and fix this properly, because like I really like the idea. So in general, when you run stuff on CI, it's very hard to get precise timings in reasonable amount of time. And that's why we do not have performance tests which just check that stuff completes faster than like X seconds, because that would be just too flaky to run CI. But the idea here is that, like, yeah, while like specific performance would be very different, you can actually try to test for correct asymptotic behavior. You can actually run your highlight and for files with like length 2, 4, 8, 16, blah, 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 and check if the result looks like linear function or if the result looks like quadratic function. I wrote some very sketchy code here, and the problem with this code is that it, like, we know that it doesn't actually catch all the quadratic things which are happening. So we fixed at least one quadraticness in the code while we were working on it. So and the reason for that, I suppose, the reason for that is that like this is kind of like very sketchy code. Basically, what it does is that it like computes some like linear regression and then just like eyeballs some parameters which are like completely random. There is like a proper mathematics here to select which model better describes the data, a linear one or a quadratic one. And it would be cool to code something like that to actually catch these kinds of errors. Okay, yeah. So actually, before we go to coding the thing, something no. It always happens. Let's actually just time this thing. Do I have to, okay, so I have this useful utility which prints the amount of time. And where did we? How do they call that thing? Something about quadratic. Yeah, is it quadratic? Okay, so let's actually say that n is equal to something like 10,000 and see what kind of printout we get there. I really don't like how long it takes to compile. Okay, so you see that it takes some amount of microseconds, like close to half of a millisecond. Like half of a millisecond is a whole lot of time, like even in the debug mode. So this probably could be optimized. Okay, so let's now switch to parser implementation. Also kind of like tip, when you try to refactor something, do not modify the stuff in place. Instead, try to instead try to like write the new code alongside so that you can easier compare two versions. And here yeah, like this can be optimized further. So what happens here is that we store syntax node pointer twice, once in arena and once in map. And actually, like this thing could actually be a hash set which stores just integers which point here. Like I don't know if you've read my call side dependency injection blog post. That's what I'm talking about. Like anyway, that's probably not important because a syntax node pointer isn't too big of a data structure. Okay, so let's say for x in s. No, what like? I wonder. Okay, so arena. I wonder iterator of what arena is. Okay, so it's ID and item. I guess I should better. Okay, yeah, because it's a standard library type, so I don't implement all the APIs, and that means that I'm sometimes surprised myself. As okay, let's just do this in a nicer way so we can size it properly. And I want to map here, so I have x and ptr, and I want to map this to ptr and idx. Okay, so presumably this is going to be yeah. When you use an ID, use the terminal to get the error. Found a reference. Yeah, because we need to dereference this. Okay, and the syntax not pointer doesn't implement the copy trait, which is very deliberate, and this is actually a good argument. I hate how the terminal steals all of my key bindings. Yeah, that's actually a good argument for not storing syntax not pointer twice here. Can I? It's yeah. I'm going to need hash brown for that. Okay, and let's actually have this time it back here. If I recall, last time we get half of a millisecond in debug mode, like still bad. Let's see if we can get this significantly faster. Yeah, it does seem like it isn't slowing down, and the total time is also like somewhat faster. So let's check our. No, before we do this, let's actually remove this time it because it's going to slow us down. Would be great if Rust Analyzer could just remove unused imports automatically. Someday it will, probably. Yeah, definitely. The secret trick here is drinking the pu'er tea. Okay, yeah. We spent a lot of time compiling that, only to realize that I actually changed the thing. Okay. So this is more like it, I hope. Okay, so 32,000 takes a second and a half, and last time took 2 seconds. I wonder if this actually. Well, it is a sizable win, you see. So this line, we spent 14 seconds here, and here we spent only 6 seconds, which actually, yeah, like you see the numbers seem to line up pretty nicely. Yeah, yeah, you see. If you multiply this by 2, you get exactly this. And if you multiply this by 2, you get this. Wow. Wow, that's that's exciting. That means that we kind of like fix like our fifth accidentally quadratic code pattern during highlighting, and it looks like this actually is the last one of those. So now our highlighting actually is linear for real. So like 25 seconds for 5 to 4, and like yes, so like you see that's like massively faster. I like it. I like it. Okay, so um, again, it would actually be cool if this like syntax highlighting is not quadratic function actually told us that our syntax highlighting is in fact quadratic, because it was. But well, kind of like machine learning is hard. I cannot do machine learning, so if someone is able to come up with a better assert linear implementation which actually flags the original implementation is quadratic, that would be super cool. Okay, so let's see. Like the changes surprisingly, and we don't need this index. Changes surprisingly small. Okay, let's restore this here. And like yeah, the drawback of append only refactors is that you always forget to actually remove commented out code. Okay. Okay, this performance optimization, I usually like to tag performance optimization as features. Accidentally quadratic code path from highlighting. Okay, let's like linear. Okay, and here I need to quickly you'll notice that what's the ID map? How is it called? AstIdMap. Does a linear lookup when going from syntax node to ID. This needs to quadratic overall performance. Replace linear lookup with hash map. Should work. Don't duplicate syntax node ptr in AstIdMap and switch to goal side and then see injection style storage. That is for hash set as SD ID. I hate typing long commit messages, especially when I make typos. See the definition of the org here on YouTube. Okay. Now let's see if that actually affected if it actually affected overall benchmark. It would be nice if it did. It would be especially nice if the change is strictly better. I fear that with an extra hash map we might regress memory usage somewhat, but I hope that we do not regress it too much. Okay, so target trust analyzer baseline, and then this is stats dash memory usage, and let's run this 3 times. And yeah, let's run this 3 times as well. Yeah, so I'm like I'm pretty bad with using fancy statistics. Okay, so the right one is actually slower, which doesn't seem like a good sign. Yeah, we'll see. Yeah, so I'm not a huge fan of using fancy statistics for benchmarking. So the way I like try to verify any kind of performance result is just to run the thing 3 times, and if it is like clear with the naked eye that the thing's better, then things better. And if I need fancy statistics to explain statistically significant difference, Um, then probably the change isn't worth it. Okay, so far this doesn't look reassuring because it seems that we regressed memory usage somewhat. And memory usage is kind of important. And also, like, we also regressed. Well, we regressed to time, but didn't regress the instructions, so it's unclear. Yeah, I don't fully understand why I see a slightly slower wall clock times here, but the same amount of instructions and the same amount of memory. Yeah, I'm torn about this. I wonder if we always need to fill this hash map, or it is org to do this the first time we compute it. Okay, this also. So yeah, one thing I'm thinking about is that we do not necessarily need this map every time. Let's actually do like the full optimization I have in mind. So yeah, basically my hypothesis is that the code path for mapping back we hit pretty rarely. So it makes sense for us to allocate this map lazily. And for that we will use one cell. Okay, and here this would be one cell, sync one cell. Actually, you know what? Struct AstIdMap with map. I will do this in a horrible way. I will store a pair here and Okay, so this is going to be that or init. Okay, like collect, and I want to. No, I don't need a browser. Count. Okay, so does this thing still compile? No, it doesn't. Doesn't implement debug. Well, of course it doesn't implement debug. Okay, because we want actually to have a count here. Okay, now this seems to work. And again, I hate how terminal steals all of the shortcuts. That's not cool. Okay. Now I think we can run analysis stats and let's see what array count tells us. Not sure if analysis stats will be representative, but even if analysis stats tells us that we don't actually need this map for every AstIdMap we create, then that's going to be cool. And yeah, like while the code is compiled, like it still grates me that syntax note pointer is stored once in the arena and once here. So ideally, we should store it only in the arena, and in the hash map we should store only the indexes, but those indices should have like a hash semantics as if they are pointing into this arena. Yeah, and now I think this will take quite some time to run because counting is pretty slow. but this should give us a nice understanding about the runtime behavior of the code. And yeah, it's interesting that yeah, like when the program you're working with is large enough, like okay, hey, this is nice. So you see, uh, during analysis stats, we created this many AstID maps, but only this many AstID maps, so like 1/3 or thereabouts, actually required us to compute that backend map. Okay, linear, oh, linear lazy. Let's call it this way. And that means that our optimization actually makes sense. Okay, well, let's. I'm debating. Yeah, let's just simplify the things. Yeah, to make sure we are debugging the thing we actually want to debug. I wonder if I can do like yeah, well, no, it would be cool if this worked, but it doesn't. To do not store. It feels like I really want to do this optimization, but I actually think that the thing we did just now with lazily allocating those mappings is the most important, is the more important one. Let's actually put this here because it feels sort of like a constructor. Okay, so now let's redo our little exercise. Linear lazy. Really nervous about this one. It doesn't seem better. And now I actually don't have like the scroll back buffer from the last time, so I don't. Yeah, I can't actually see if that's. If that is a meaningful savings. Oh, well, yeah. Yeah. Well, actually, I don't need a scroll back buffer because I can just run this. And as this is run in a single threaded mode and I have a plenty of CPUs on my computer, I don't think there should be any difference. Okay, so it, yeah, yeah, don't understand what's going on because the counters told us that this should be significantly better, but it isn't actually significantly better. In fact, it seems like it is not better at all, which is very strange. So yeah, we keep this in empty. We allocate it on the first axis. Yeah, really don't understand what to think of this. Okay, yeah. Well, let's commit this just so that we have this stored in our Git history and then come back to this later. Try to optimize things and successfully. And let's remember a couple of benchmarks. So this is baseline, eager, and lazy. I'm picking the second run because it should be warmed up. No, this one was eager. And this one was lazy. Okay, and let me try to submit this pull request. Not sure where this will end. We'll see. So, thank you for listening and watching, and see you next time.